In this video, we'll be looking at how to solve these questions in indices. And so if you have not subscribed to this channel, kindly subscribe for more updates. Let's get started. And so we have our question as 9 exponent 1 out of 3 times 27 exponent negative 1 out of 2, all divided by 3 exponent negative 1 out of 6 times 3 exponent negative 2 out of 3. And so to solve this question, we can see that they have different bases. So we have the base 9, you have the base 27, you have the base 3, and the base 3. And so we'll have to ensure that these bases are the same. And in doing so, 3 seems to be a base that cannot be changed. But we can go ahead and change 9 as 3 times 3. So possibly we know that 9 is equal to 3 times 3. That is equal to 3 exponent 2. And so we can change 9 for it to have a base of 3 and an exponent of 2. In the same way, we can also change 27 to a base of 3 and exponent of 3. So simply put, we know that 27 is the same as 3 times 3 times 3. So that is 3 exponent 3. And so if that can be done, then we go ahead in doing so. So our solution now becomes equal to, so right now we said 9 can be written as 3 exponent 2. So we write 3 exponent 2. Then our existing exponent 1 out of 3 comes times, we also said 27 can be written as 3 exponent 3. And so we have 3 exponent 3. Then our existing exponent negative 1 out of 2 comes. Then since 3 cannot be changed, in this case we maintain it. So we have 3 exponent negative 1 out of 6 times 3 exponent negative 2 out of 3. Now, having known this, then we can multiply the exponents at the numerator. And so we continue, and we have 3 exponent. Now 2 times 1 out of 3 is 2 out of 3 times, now 3 times negative 1 out of 2 is negative 3 out of 2. So we have 3 exponent negative 3 out of 2. Now all divided by, we maintain the same values for the denominator, and we have 3 exponent negative 1 out of 6 times 3 exponent negative 2 out of 3. Now having gotten this, then we proceed. So at this point, we can see that at the numerator, we can see that the bases here are the same, and at the same time the bases are multiplying. And indices, we said if we have the bases to be the same and at the same time they are multiplying, we said we can add the exponent. We can add the exponent. So with that idea, then we are going to apply that to the numerator. And so we continue, and we have 3 as one of the exponents. Then we are going to add the bases. So we have 2 out of 3, then plus minus 3 out of 2, all divided by, so the same thing applies to this one. We can see that the bases here are the same, and at the same time the bases are multiplying. So if that happens, we are going to write one of the bases and add the exponent. And so we continue, and we have 3. So we have 3. Now we add the exponent negative 1 out of 6 times, so plus minus 2 out of 3. Now we simplify, and we are going to maintain the base, and we know that 2 out of 3 plus minus 3 out of 2 is the same as 2 out of 3 minus 3 out of 2, all divided by, so maintain the base for this, that is 3, and minus 1 out of 6 plus minus 2 out of 3 is the same as minus 1 out of 6 minus 2 out of 3. And so we simplify our solution, and we all know that 2 out of 3 minus 3 out of 2 gives us minus 5 out of 6. And so we have here as, so maintain our base, and when we sum these two numbers, we are going to get minus 5 out of 6. Now divided by, when we sum minus 1 out of 6 and minus 2 out of 3, then we are going to get, we maintain the base as 3, and we are going to get the exponent as minus 5 out of 6. Now, having known this, then we continue, and we can see that the base are the same and they are also dividing. So we can also rewrite this as 3 exponent minus 5 out of 6 divided by 3 exponent minus 5 out of 6. And in this is, we said that if the base are the same and the base are dividing at the same time, we subtract the exponent. So if that's the case, then we continue, and at this point we have, write one of the bases and we subtract the exponents. We have minus 5 out of 6 minus and minus 5 out of 6. That is, we subtracting the exponent. And so if that continues, then we have here, so we write the base as usual, and we have minus 5 out of 6. Now minus minus, when minus minus meet, we get positive, so plus 5 out of 6. Now we all can see that minus 5 out of 6 plus 5 out of 6 gives us 0, and we have 3 exponent 0. And so in indices, we said that any non-zero number of an exponent of 0 equals to 1. So our final answer is equal to 1. And so we take the next example, and in the next example, 25 exponent 2 out of 3 divided by 25 exponent 1 out of 6, or divided by 1 out of 5 exponent negative 7 out of 6 times 1 out of 5 exponent 1 out of 6. So in this case, it means that I have to change the 25 for it to have a common base as the 1 out of 5 we see at the denominator. So since 5 cannot be changed to a different base, then we have to tackle the 25. So we know 25 is the same as 5 times 5, and that is 5 exponent 2. So we can change 25 to 5 exponent 2, and we continue with our solution as such. So it means you have is equal to, now 25 is now 5 exponent 2, and our existing base, our existing exponent rather, so our existing exponent is 2 out of 3. So we have 2 out of 3 divided by, now 25 can be changed to 5 exponent 2, so we have 5 exponent 2 here, and our existing exponent as 1 out of 6 divided by 1 out of 5 negative 7 out of 6 times 1 out of 5 1 out of 6 as the exponent. So with this idea, then we can multiply the exponents. So we have 5. Now 2 times 2 out of 3 is 4 out of 3. So we have divided by, now 2 times 1 out of 6 is 2 out of 6. So divided by, now we know 1 over 5, that is 1 out of 5. 1 out of 5 can be written as 5 exponent negative 1. So that is from the properties of indices. We said if we have 1 out of e, then can be written as 1 exponent negative 1. So we can implement that in our solution. So it means we have 5 exponent negative 1, 5 exponent negative 1 multiplied by negative 7 out of 6, and in the same way we can also change this 1 out of 5 to 5 exponent negative 1. So times 5 exponent negative 1 multiplied by 1 out of 6. And so we continue, and before we simplify the numerator, let's maintain it and simplify the denominator also. So 5 out of 5 exponent 4 out of 3 divided by 5 exponent 2 out of 6, all divided by, now negative 1 times negative 1 out of 6 is 5 exponent 7 out of 6, times, when we multiply these two, then we're going to have 5 exponent negative 1 out of 6. So with this, then we can simplify the numerator. Now we can see that they have the same base, that's a common base of 5, and at the same time the bases are dividing, so we can subtract the exponent. So we continue, and we have 5 exponent 4 out of 3 minus 2 out of 6 divided by 5 exponent 7 out of 6. Now we can see that they have a common base of 5, and the exponent a common base of 5, and the bases are multiplying, so we add the exponent. So we have 5 exponent 7 out of 6 plus minus 1 out of 6, and we continue with our solution. So at this point we have 5 exponent 4 out of 3 minus 2 out of 6 divided by 5 exponent 7 out of 6 minus 1 out of 6. You know, when positive and negative meet, we are definitely going to have a negative answer. So now we simplify the numerator, and we know that 4 out of 3 minus 2 out of 6 is 1. So we have 5 exponent 1 divided by, 7 out of 6 minus 1 out of 6 is also 1. So 5 exponent 1. So if that continues, we know 5 exponent 1 is 5, and 5 exponent 1 here is also 5. And so at the end, we are getting 1. And so this is our solution to the question, and this ends today's video. And so thanks for watching. Kindly like, comment, subscribe, and share. See you in our next video. BakoMaths, thinking beyond infinity.